Alright guys, today we're continuing on with visual perception principles. And today we're looking at depth perception. So depth perception is our ability to accurately estimate the distance of objects around you and perceive the world in 3D. So seeing that things go off into a distance as opposed to get smaller. This will make more sense when we go through these depth cues, which is our ability to locate objects in space. What's a depth cue? It's a source of information from the environment, an external depth cue from the environment, and within our own body. And we have internal and external depth cues. And they can be split into two groups. There's binocular depth cues and monocular depth cues. Now, those words alone should give you an idea of what they are. So binocular, think about binoculars that you use to look at things from far away. You're using two eyes. Bi meaning two. Ocular meaning eyes. Monocular, mono, like a monorail, is one. So mono means one, so it's one eye depth cues. So two eye depth cues and one eye depth cues. So looking at our two eye depth cues, it requires both eyes working together to give information about depth and distance. So we're looking at convergence, retinal disparity, and we're going to start with convergence. Can't do this activity, so we're going to skip it, but see if you can do this with somebody at home. So you get one person to hold out a finger at arm's distance and focus on that finger as they bring it towards your nose, and somebody else has to observe them. So ideally you want to be the person observing someone else doing this. And this is what convergence is. So it's the brain detecting and interpreting changes to eye muscles as two eyes turn inwards. So basically you're kind of going cross-eyed. You might feel it as you do it, but you can certainly see somebody else do it. So what's happening is your pupils, your eyes, are converging together as you get closer. So we call that convergence. And it works best when it's within 6 meters. Once you start getting beyond 6 meters away, it's such a small difference, your body struggles to tell the difference. So here you can see in this picture, from very far away, the eyes stay pretty centered. As you get closer and closer, those pupils are getting closer and closer to the nose. So your body's picking this up and you're having to use both eyes to determine this. So your body picks up how close your pupils are together and makes a determination about the distance. So other binocular depth cues, retinal disparity. So you have noticed this before, I'm sure. If you hold out a pen and close your left eye, and then swap over and close your right eye, and you compare where your pen is compared to the background, you'll notice that your pen actually moves. Now it's not your pen moving, it's the fact that your eyes are slightly different distances apart. And we call that retinal disparity. So it means that your retina is not in the exact same spot as the other retina. So slight differences in location of visual images get cast on the retina. And we need to always talk about this in terms of the image cast on the retina. And everything we do with depth cues is about that image that gets cast on the retina that we talked about when we looked at the eye the other day. So when the two images get combined in the brain, not the Brian, the differences give information about the depth or distance for the viewer. So the more there is a difference, the closer something is. The less there is a difference between the two eyes, the further away something is. And this one works up to 10 meters away. So you can do it, as you can see in this picture, with your finger. If you look at it on the left eye, and then you look at it from the right eye, it changes what you can see. All right, monocular depth cues, one eye. So again, just one eye gives us the information about the depth and distance. And here we're looking at accommodation and pictorial cues. Now, accommodation isn't where you stay. It's the automatic adjustment of the shape of our lens, as we discussed with the eye, so the shape of that lens, to focus on an object in response to how far away it is. So basically what's happening is your brain is detecting changes to the shape of your lens or the movement around your lens, and that helps us determine how far away that object is. And it does it through the ciliary muscles. So if you go back to that image of the eye, the ciliary muscles move that iris and change your lens shape. And as it does that, your brain picks up those changes and it helps it determine depth and distance. So when the lens bulges, the object is close. And when it elongates and gets quite wide-eyed, then something is further away. So here you can see the lens is bulged because it's quite wide along here. And so that vase is quite close. And it's elongated as it's taking in this information of the vase from further away. Right, pictorial cues. These are things used by artists to create distance and depth in two-dimensional pictures. So if any of you do art or visual communication, you may have used these before. So we're looking at linear perspective, interposition, texture gradient, relative size, and height in the visual field. And as I said before, these really need to be spoken about in reference to the image cast on the retina. So here you can see in this painting, a few things that you'll notice straight away. The river goes back on an angle, right? It's not a straight line even though it's supposed to be parallel. This person is a lot smaller than this person. So let's start with linear perspective. And that's what I was talking about with the river before. So it's the apparent convergence of linear lines as they approach the horizon. So in this image you can see a road would be parallel. But you'll see in this image they seem to converge or come together towards the horizon here. And it's not just on the road. You'll notice that with the building, everything is coming to this one point on the horizon. Interposition. Hopefully the word itself helps tell you what it is. It's when the object is partially blocking or covering another. So the position of those particular objects. And the object that is covered is considered to be further away. So here you can see in this example, this present would be considered to be furthest away because it's blocked by this present, which is blocked by this present. Okay, so this would be the closest, and then this one would be the furthest away. You can see the same here. The closest blocks this one, which blocks this one, which blocks this one, which would be the furthest away. Texture gradient is looking at the texture, the detail of the surface, and the gradual reduction of that detail as it goes into the distance. So here you can see a lot of detail in this picture, lots of cracks. As we get back here, it's just sort of a colour that you'll see. So the texture, the detail of that surface disappears as it goes further into the distance. Same with our sand here. We're getting lots of little dots, lots of focus. We can see each individual grain and just becomes a blur as we get further into the distance. Relative size. Now this is our tendency to perceive objects that cast a larger image on the retina as being closer. So these balls we perceive as being the same size, but this one is further away than this one than this one. In actual fact, they're just smaller versions of the same ball on a two-dimensional shape. But we perceive this is a closer ball because it casts a larger image on our retina. So if we were to move the man in the background here to be in what we perceive as the same distance, he looks very tiny. But when we put him into the picture in where we believe he belongs, he looks like he is the same size. Right, our last one, heighten the visual field. And again, we're talking about our retina here. So this refers to the position of objects in relation to the horizon. Objects closer to the horizon are further away, and objects further from the horizon are considered to be closer when that image is cast on the retina. Now this works in two ways. A lot of times people will get confused and just say the further down the picture, the closer it is. It's all about the horizon. So, the further away from the horizon the image is, then the closer it appears. So in the sky, that means it's going to be higher in the picture. On the ground, it's going to be lower in the picture. So it's all about the distance from the horizon. Oh, nearly forgot this one. All right, so pictorial cues. We need to identify, if you can, all of the pictorial cues in this image. You'll be able to see linear perspective on our road. Even on the lines here, they are gradually converging to the horizon. Interposition, so the beetle here is in front of the beetle here. The lamppost is in front of the tree. And so those that are in front look closer. Texture gradient. We're getting a lot of texture of the road here. Very little detail back here. Same with our trees. Very little detail here. You can almost see individual leaves up here. Relative size. So this car here is a lot larger than this car here. And then heighten the visual field. So again with the cars, this one's further away from the horizon than, for example, this car here. So this one is considered to be further away than this because this is at a lower distance in the picture from the horizon. Alrighty, enjoy.